All right, item number 3 here. I recreated that quadrilateral ABCD with AB equal to 3, BC equal to 4, CD equal to 5, and then the angle measures for B and C are both 120 here. I figured the easiest way to go about doing this was to create a parallel line here that parallel to AB that goes through C. So then we have a trapezoid up top and a triangle down here on the bottom. So we'll have to add a point here. So we have both these shapes. And then I know that the area of a trapezoid is the bases added together divided by 2. So the parallel sides added together divided by 2 multiplied by the height. The height here is going to be this point here. So this distance from E to line AB at that point is going to be the height. And we're also going to need to know the distance from E to C here for the other base. So we have 3 plus 3.89 is equal to 6.89. Divided by 2 is 3.445. Multiply that by 3.46 to give us the area of the trapezoid to be 11.9197. And then we also need to know the area of this triangle down here. So the area formula for a triangle is base half, 1/2 base times height. So the base here, we're going to use 5. And then we'll also need to create another height here from E to here. So that intersection point there. So this little line here, EG, is going to be the height of our triangle. So we're going to have 5 times 3.37 times 1/2. That's going to equal 8.425. And then to find the total area, we just have to add those up. So we'll add up 11.9197 plus 8.425, and we come to our final answer of the area being 20.3447 inches squared, centimeters squared, something squared, you know.